For centuries, time has been viewed as something that moves in only one direction: forward. Once a moment passes, it is gone forever. This idea is so deeply rooted in everyday life that reversing time has always seemed impossible, reserved only for science fiction. However, recent laboratory experiments have challenged this intuition, showing that under very specific conditions, time reversal effects are not just theoretical, they can actually be demonstrated. In a groundbreaking experiment, scientists managed to reverse the behavior of electromagnetic waves using advanced materials known as metamaterials. These are not naturally occurring substances, but are carefully engineered to control waves, such as light, radio, or microwaves, in extraordinary ways. By rapidly changing the properties of these materials while waves were traveling through them, researchers triggered a phenomenon called time reflection. Normally, when a wave hits a mirror or boundary, it reflects back in space. In this experiment, however, the wave was reflected in time instead of space. The wave retraced its previous evolution, behaving as if time had briefly flowed backward. To measuring instruments, it appeared as though the wave had undone its own past motion. It is important to clarify what this does and does not mean. The experiment did not reverse time for people, objects, or the universe itself. No clocks ticked backward, and no past events were altered. The effect applied only to the controlled behavior of waves within the laboratory. The fundamental laws of physics, including the second law of thermodynamics, which explains why time moves forward in everyday life, were not violated. So why is this discovery important? Beyond its mind-bending implications, time reflection has real technological potential. It could lead to new ways of correcting distorted signals in communication systems, improving radar performance, and recovering lost information in data transmission. In environments where waves scatter or degrade, reversing their evolution could allow engineers to reconstruct signals with remarkable precision. This research also sheds light on the nature of time itself. While time feels irreversible on a human scale, many of the equations that describe physical systems work equally well forward and backward. Experiments like this reveal that, at smaller scales and under carefully designed conditions, nature allows behaviors that seem impossible in daily experience. In the end, scientists have not built a time machine, nor have they unlocked a path to the past. What they have done is equally impressive. They have shown that time, when viewed through the lens of physics, is far more flexible and mysterious than it appears. As research continues, these discoveries may reshape both future technology and our understanding of reality itself.